Good afternoon, everyone, and welcome back to the afternoon session of the general meeting. It's with great pleasure that I'm introducing Brad Wolcott to be able to spend the next couple of hours with us to talk about various types of woodworking experiences he's had, as well as some of the pieces that he has developed over the years and some of the ways that he puts it together. Brad is classically trained as a studio furniture maker. He combines contemporary design with sensibilities into the finest materials available to create unique pieces of decorative art, which that is certainly an example of. Brad has, over the years, gone over to Hopkins Center Woodworking Studio and has been awarded the Hyman Rosenthal Achievement Award for Creative Arts and after graduation, after you got out of the military, and thank you very much for your service, by the way. And you enrolled in North Bennett State School of Boston, and take it from there. Thank you for being here.
Thank you.
Done that before.
So as I said, my name is Brad, and today I'm going to be talking about tapered lamination with a twist. Just to expand on my biography a little bit, I was raised in Concord, New Hampshire, and started working a little bit in high school, but then primarily at Hopkins Center Dartmouth College. And after I graduated, I spent 4 years as a cavalry officer in the Army, stationed in Germany, and then spent time downrange. And then when I got out, I moved back to Boston, went to the North Bennett Street School, and graduated a year and a half ago. And since then, I've been working at a shop in Charlestown, and I'm getting ready to move out to Central Massachusetts and I go to work in Hardwick. So my talk today is going to be on tapered laminations, and for that, I'm using this music stand as my reference. Some of the topics that I want to talk about are the purpose of laminations, the materials and equipment that I use to create that work, form construction, lamination preparation, glue up, clean up, and shaping. The slideshow up here there's some figures and pictures that I'm going to use to hopefully clear up some of the things I'm talking about, and then I'm going to list the topics of discussion and the subtopics for each part of the briefing. So it's not going to be a massive PowerPoint presentation. I'm trying to organize it more like a cooking show. I have all of the pieces pre-made, and I'm going to walk through the steps. But in order to try and cover as much material as possible, I'm not going to fully do all the cutting, do all the shaping right now, because I would only be able to get through a tenth of this talk if I was just building a tapering sled. So I think hopefully you guys will find it more beneficial to see a wider range of topics and see the whole process from start to end. And this is going to be an open talk, so if you have questions as I'm going, please feel free to ask, and we'll go from there. So the first topic I'm going to talk about is the purpose of laminations. And I know that we have all levels of skill and experience in this room, but what many of you may or may not think is that bent tapered laminations are a new technique or are primarily used in contemporary furniture, and that's not true. I picked 3 examples that show, the one on the top right is from Jerry Osgood, which is a very contemporary piece, and Jerry is one of the, he is sort of one of the men who made this technique popular in the last 30 years through his work at Boston University and through his work. Below that, there's a piece by Mario Messina, who taught at Dartmouth. I took a workshop with him when I was a student, and that's obviously a very contemporary piece and very sculptural, and you can see the flexibility that tapered laminations can give you. Each one of those sort of arms on the are bent paper laminations that he free-formed in space. And then the picture on the left is a table by David Lamb. And many of the aspects of this table, which is much more traditional, incorporate bent laminations. The front of the top, the molding on the front is a lamination. The laminations aren't tapered, the plies aren't tapered, but it is a bent lamination of mahogany, and that's how he gets a continuous space and then can mold through. As well as those stretchers on the bottom, those are also laminations that are veneered over. So as we go along, whatever your area of interest is, I think that there are ways that you can incorporate this technique into your work and find it to help you work more quickly and to get stronger, longer lasting products.
What's the size of the
It's quite small. It's maybe a little bit, it probably stands about the height of this form right here, maybe a little bit taller, but the arms are very, very slender. Down to, obviously the taper costs nothing, but even at the thickest part they're not much more than a quarter, 5/16, 3/8 of an inch round. So why do we use bent laminations? The primary reason for me is strength, and the second is design possibilities. Because when you make a lamination, you are using plies that look like this. And let me step back a second and go over terms I'm going to use in the talk. The first is blank. So when I refer to blank, I'm referring to the piece of wood that I cut the plies out of. This is a ply. It's a single piece cut from that blank, and a pile of plies glued over a form are a lamination. So that's how I'm going to use those terms in this talk, just so that we're all on the same page. When you cut a ply out of a blank, you want to use the straightest grain material possible. And by doing that, you ensure that there is long grain running the entire length of this ply, so that when you bend it over a form, you are incorporating the strength of that long grain into the form. If you look at the music stand here, envision if this was cut from a single board, and the board went up like this, so the grain direction is going to be running through the board like this. At this point here, the long grain runs out of the stem, right? And you're going to have a very short grain area all the way up that's going to be very prone to breakage. If you drop it, the stresses could easily break that shape. In addition, you need a huge board to be able to cut this curve out of it. So you're going to waste a lot of material if you use solid. Is it possible? Yes. Is it faster? Yes. But it's not as strong, and you are going to run the risk of damaging or breaking it if it gets knocked over, and you are going to lose the strength of having that long grain. So that's why, for strength reasons, laminations can be incredibly useful. And the base of the music stand illustrates that to an even greater extent. This is also a bent tapered, it's a double taper lamination. If you were trying to cut this out of a single blank, half of this would be, extremely short grain. When you put it down on the ground, you kicked it, you knocked it over, it'd be very prone to splitting and breaking off. Whereas because I used plies that look like this, they're very straight grain walnut, and bent them around the form. This shape maintains the integrity of that long grain and is extremely strong. So you really don't have to worry about it breaking there. So those are the two reasons that I think bent paper laminations are a really useful technique to know. The last one is material conservation. For most of us, it's not that big a deal. The amount of walnut that you're going to save by using this technique versus using a bigger board is, at least for me as a professional, is not worth the time. Cutting it out of a solid is going to take a lot less time, and the extra material that I'm going to save is not worth more than the time I would save doing all the steps. But if you're using rare woods, ebony, satinwood, something where you're limited in size and you want to create a shape, this may be the only way that you can achieve that. So the next thing we're going to talk about are materials and equipment that you need. The first is wood choice. In contrast to steam bending, bent tapered laminations essentially allow you to use any wood available. Unlike, in steam bending, you're limited by many of the physical qualities of the wood. So some of the more brittle, dense, hard exotics do not bend well. And when you steam bend them, the steam is not going to allow those fibers to bend much more than they would dry. Whereas with the bent tapered laminations, because you're cutting them so thin, you can overcome that. And as long as the curve isn't very extreme, you can get them to bend around just about anything. So one of the things it allows you to do is not be limited by material choice. And you can really choose materials based on the design that you are trying to achieve. And I like that flexibility. Now sometimes if you're trying to achieve a really tight curve, there are materials that are better, and those would be the standard bending materials: hickory, ash, maple, things that have high, I can't remember the technical term for bending strength. What is it?
Lincoln?
No, it's the term for bending strength. But anyways, so
Modulus of elasticity.
what's that?
Modulus of elasticity.
Yes, modulus of elasticity is what you're looking for if you're trying to achieve a really very severe bend. So once you choose your materials, the next thing you have to choose is your bonding agent, whether that's glue or epoxy. And that's going to be dependent on your wood choice. There are two bonding agents that I think are appropriate for bent tapered laminations in most scenarios. Unibond 800, which is a 2-part urea formaldehyde glue, or epoxy. And the only reason that I would use epoxy instead of Unibond is that if you are working with an oily or acidic tropical wood, and for that you would use something like System 3 G2, which is specifically designed for bonding those oily acidic woods. The reason that I would always choose Unibond above epoxy is that Unibond dries, is much more brittle and harder than epoxy once it finally dries, I found. And it will hold curves better, it has less spring back, and I've had a lot of success with it. I like it. It's easy to use, and I think it's very effective. One of the nice things about epoxy.
Have you had any experience with the new formulation for the Unibond?
Yeah, that's what I actually used for this, the lower formaldehyde version. It was fine.
Okay, you haven't.
I haven't seen any difference. There is a third type of bonding agent that you could use for bent tapered laminations that has all the characteristics that you want. That's called resorcinol. It's an older product that's been used in the boat building industry for years. The reason that I don't include it on this list is because resorcinol has no gap filling ability, and the glue lines need to be extremely tight, and you need to apply good pressure to all of those, and if you don't, it's going to fail. One of my classmates at school was a boat builder for a couple of years, and he said that working with resorcinol, it's incredibly waterproof, it's totally weather resistant, but if your joints weren't super tight and well clamped, it would fail. And with laminations, when you have lots of joints, in between the layers, on the base of this, there are 14 plies. which means that there are 14 glue lines that I need to be tight. And having a little, Unibond has a little gap filling ability, and epoxy has a lot of gap filling ability. So you want to have that sort of added safety of, okay, hey, the planer sniped this part a little bit. I need a little glue to fill in that area. You're not going to get away with murder, but sometimes those little hairline cracks you will disappear using those products, and if they're sourcing on, you'd be in trouble. And then, so those are the bottom mediums I would use. The last thing is clamps, and this is a huge part of bent tapered laminations. There are old clamp companies in the United States, Hartford and Wetzlar. They made great clamps, good iron bars, solid steel jaws, had a lot of clamping pressure. They've gone out of business in the last 10 years, and the bar clamps that are available now, like these Bessies, some of the Jorgensen bar clamps, their like max clamping pressure is anywhere from 1,000 to the best ones are 1,500 pounds. And for a really strong bend with a lot of laminations, that's not sufficient. If you're doing really intense bending like the base of this, you need more clamping pressure than that. And the only bar clamp that's still being made for sale that I've found to be really good is by a Spanish firm called Piher. P-I-H-E-R is in the handout. They're sold by Woodworkers Supply. They're rated for 2,200 pounds, so 700 pounds more than the best Bessies and Jorgensens. And it seems crazy, like when you do most woodworking projects, you put these things on, they'll close any gap. But when you get to bent tapered laminations, the amount of force that you're trying to exert and the amount of force that those plies are exerting back on the clamp can be incredible. And you just won't be able to close them. They just won't have and they'll start bending, and you'll see these bars just flexing back like you wouldn't believe. And so having the best clamps and the most clamps that you can afford is, so that is the stem that I clamped up. And hopefully you can see the number of clamps that I have on that. Give you some sense of how many clamps you need. And that can be modified by how severe the bend is. But I think I used 40 something clamps on this. And for the areas that were straight, like here, I just had a block, and I just used like a double form. But for the areas where the taper was stronger and there was a twist involved, you need a clamp every 2 inches to exert enough pressure to mold it to the form and keep it in place. So that's one thing to consider before you get started with this. Whether you're borrowing them or you have them in the shop, you always want to test out before you put glue on it. Test out to make sure that your clamps are going to be strong enough to do it. Because the worst thing in the world is when you start putting these things together and you realize that you can't get it that last 2 inches at the end of the lamination, and then everything you've done up to that point is not going to work.
You got all the clamps are facing the same direction. Does that have anything to do with alternating them, or should they all be this way? Or?
The reason is, you mean that the fact the bars are all pointed up?
That they're all put on this way. I was told you should have them alternating, so you have
They're on both sides. You can't see it very well, but
okay.
When we get to form construction, I'll talk about, and you can see this is the first part of the, when we get to form construction, I'll talk about the forms that I make, how I do them, and why that allows me to have clamps on both sides.
All right.
So.
Can I back you up a bit?
Absolutely.
Design,
Okay.
where did you come up with what were your design priorities that went into coming up with this in your mind and then rendering it on paper, I suppose?
Yeah, absolutely. No, that's a fine question. So the inspiration for this piece was a musical note. And if you look at the base, it sort of looks like the round part on the bottom of the note. And then these 4 flags are referencing a 64th note. So the flag's in the 64th note. And I just twisted that shape in space to create, you know, something that I thought that design-wise that it was a good way of incorporating the spirit of the piece into its purpose. And it also allowed me to use a pretty minimal form in the number of pieces, despite the fact that technically it was extremely difficult. And one of the hardest things I had was the drawing, because you can see that each one of these pieces, particularly the stem and the intersection with the base, are curved in 3 dimensions. So the stem curves backwards, it's angled, and it is tapered. So when you do a standard drawing, for those of you who draw full scale, or any scale for that matter, if you were to draw the standard front view of this, you wouldn't be taking into account the foreshortening of space. The same thing with when you drew it from the side angle. When you look at it from the side, you think that you're getting a true perspective perpendicular to the base. But because the piece is angled backwards, if you were to draw it on a piece of paper like it looks from the side, it would make it shorter. The final product would be shorter because of the foreshortening. And because I wanted, you know, one of the few requirements I had for this piece was that the rests needed to be centered over the middle of the base so that it would be stable, and that there would be a good distribution of weight when you had a book of music on the top. So I needed this plane to cross the center line at a given point right here at the base, so that the bottom of the stand was in line with the plane running through the middle of the music stand. And someone was asking me earlier why did I have to draw it? Why couldn't I just go for it? And it was those calculations that made it necessary to have it all down on paper, because if you twist this joint 1/8 of an inch, all of a sudden this stand could be way back over the back side, or it could be angled out over the front. So I had to know the exact angles that I needed to use to get this in line with the middle.
Did you design it for a specific musician?
I did not. I designed it for the average musician. And so it's 42 inches high, which is sort of the average height for a standing music stand. So it could be changed. I have to change the form to accommodate major changes. You know, I can move it up an inch. I can make it taller easily. I could not make it shorter easily, because the bend, this top part is flat, and the bend starts right here. This is set at a 30-degree angle to the horizontal, whereas this is where the bend starts. It starts about 3/4 of an inch down from the bottom of the rest. So I couldn't move it down and starting to move into the taper too quickly, and that would make things a little bit more complicated, because the stem would start getting in the way of the music, start pushing it off, because unless I kick that out, it's on.
Did you make an initial one out of something other than your finished materials first?
I made a mock-up out of, I used basswood. So I did all the pieces, and to get a sense of proportion and scale, and then I changed a lot of things. And I like building mock-ups too, as part of the, just following on the design process. I find that mock-ups, whether they're put together with cardboard and 2x4s, they give you a really good sense of scale that you don't get on paper or on the computer. Does anybody here use computers to draft out their stuff you bought? One of the things that I don't like about computers is that when you make something that's this big on your screen, and then it's 5 feet long, it's very difficult to get a sense of a lot of those fine proportions, whether it's between drawer runners and the sides, whatever part it may be. So doing it full size, that's the way I was trained, and I like doing it for that reason. So does that answer your question?
See, that's the most difficult part.
Yeah, the joinery was a nightmare. So the stem is twisted over its length. It's joined at an angle with a bridle. The front is a V, but the back's straight, and it's offset from the front of so the middle of the base is 3 inches to the left of this side of the stem, and it's twisting back in space. So I had to do an angled twisted bridle over the top with no flat reference, and it was complicated.
And you only had one chance.
I had one shot to do it right. So I cut the first part of the bridle on the base first, and I did that using, this is my little jig for it, so I'm skipping ahead a little bit, but I'll show you right now. I was very careful throughout the process to mark out the front line and the side line, the planes of the, so you can see on the middle of the form that I have my reference lines lined out. And I have those on the sides of the form and the front of the form. And I was very careful to transfer those marks to the base at each step of the way so that I didn't lose track of where my front line was. Does that make sense? Because that's what I needed as my reference to figure out where the joint was later. Because there's no flat on the face, it's just a continuous curve. If I had just done it, taken off the form, it would have been very difficult for me to figure out exactly where the midpoint of it was. Because there's always a little bit of spring back. It's not like it comes off this form and it's perfectly tight to the form. Even if it moves 1/4 of an inch, now all of a sudden, it's very difficult to tell where it originally was on the form. The easiest way is actually like lining up the glue drips. And if you make a mistake, that's the best way of figuring out where you are again. As crude as that is. But, so I used that as my reference, and then I was able to put a straight edge across the line that ran through the middle, and figure out how to make this jig so that it slipped down over the top of the base. And I cut the joinery here parallel to the center line, and then I sawed it out, and it was all done by hand because there's no way to do it by machine. So I cut this on the table saw. I cut this V notch on the table saw, slipped it over, marked it, removed all the material by hand, and then used the shoulders on this to register my chisel. To finish up the shoulder so that I got a nice clean straight line that was parallel to the center line. So that's how I cut the bottom. And then the top, because the back is just straight, I just hand planed it until it slid in to that notch. But the front, because it's tapered all the way down, I got it close with the saw, and then I just fit it with the shoulder plane. And as you're moving down, they're not approaching the sides in equal amounts. So you sort of have to guess how much to take off each side as you go down, because they're moving, it moves more towards this side than this side. So it's really complicated. And I was actually planning to spend too much time talking about it, because that could be like a whole couple of hours of just like cutting that joint. And I can talk more if anyone wants to afterwards. Yes?
Is the, from this view now, as opposed to the side view?
Yep.
Is the center line just as important to the top of it, where you put the weight of your musical paperwork?
It is.
It is.
It is, yes. So these flags are centered over the center as well, though they're actually offset. Each one is offset 1/4 of an inch, I think. So they're not vertical. This is 3/4 of an inch further out than this one. I figured I could get away with it, and I wanted to mirror the shape of the stem to some extent, while still maintaining that surface to hold the material on. But yeah, that was the other part about drawing it, is that figuring out where, how far over these points were in relation to the base became difficult. And, you know, despite what I did on my drawing, they ended up a little bit different. And towards the end, I can talk about how I went about ensuring that they were aligned the proper way. I used a plumb bob and basically like I clamped it onto this portion, used a plumb bob off the end to reference where it was sitting on this, and then I just moved the pieces around but before that I had to, the reason that this stem is twisted is because on the curve here, the curve comes around, it's like that, but the front of the stand is not parallel to the base of the stem. They're offset like that. So the stem had to be twisted over its length so that these flags were parallel to the front edge. And I did that by putting on a table saw, standing up behind it, clamping a straight edge to this spot right here, parallel to the ground, and then using the edge of the table saw as a winding stick. And I'd shave off, take a couple passes with the plane, and shifted it over. It had to be really close though, because otherwise I would have gone through the laminations and it would have shown up on the front. So anyways, I'm going to keep going so we can get into the more making stuff. All right. So first part of making a lamination is form construction. And this is one of the most important steps because the form is going to determine the shape of your final lamination. And it's just like, the first part of it is just like making a pattern for any project. I like to use 1/4 inch Baltic birch plywood. You could also use masonite. The reason I like Baltic birch is because it's light in color, so when you put pencil lines on there, it's easy to see, and when you cut close, it's still really easy to see the pencil lines that you can shape to. If you are using a shape, if it's for a table, let's say it's for a demi-lune that's either round or elliptical, to make your pattern, you can just swing an arc. Or actually, you can just swing an arc on the center portion of the pattern, or swing an ellipse with your router. Have you guys covered, many of you probably know how to do that. It's pretty easy, just have a reference point, you swing your router around. So that's one way. But if you're making a non-mathematical shape, a curve that you just came up with a piece of bending wood or acrylic, then you need to do it by hand. So you draw your pattern on here, you cut close to the bandsaw, and then I finish up with spoke shave. And I suppose if you're comfortable with a sander, you could do it with an oscillating sander.
Spindle sand.
Yeah, not spindle, but one of the
Edge bell.
Yeah, edge belt.
Oh.
Edge belt sander.
Edge.
That had like a long flat reference that you could get your curve off of. But I like the pencils, so that's what I do. So that's the first step, is to create your pattern. And then the second step is to get a piece of MDF that's going to be the center of your project, the center portion of the form. And when I make forms, they look like T's. And the reason that I do that is because it gives you an easy place to clamp them into the bench or secure them onto the table, the bench top. So you can see here with this form, we've just used some clamps as legs, and now it's standing up in the middle of the bench. And if all these pieces were the same size, then you wouldn't be able to clamp onto it without getting in the way of where you're going to need to clamp later. So having like a central piece that's sort of like a spine or a keel serves the purpose of allowing you to clamp it to the bench. But the second thing it does is it also acts as a way of counteracting the torque that you're going to apply with your clamps. So on this pattern, for instance, if I didn't have this central portion here, and this was not connected, then when I started clamping this, the plies are going to want to pull this form out because they're exerting so much resistance that as you're clamping, the plies are actually going to pull the form out, and your shape's going to end up different than you expected. So if you have a central sort of brace like this, now you don't have to worry about those plies getting pulled, because unless they're, if the plies are so strong that they tore a piece of MDF in half, you probably have bigger problems than your shape being bent. So that's why I use that center form, and that's why I use the T. It just strengthens it, stiffens it, and it makes sure that the form remains what you want. So start with this piece of MDF, and I'm going to screw down my pattern to the piece of MDF, right, just like that. And at this point, it's just going to look like this. All right. So now I take a pencil, and I would draw a line, and that's going to be my bandsaw mark. So I'm going to take the form off, the pattern off. I'll come over to the bandsaw, and I will bandsaw close to my line. And then I will put the form back on. So now you want to end up with about a 1/16 of an inch over where your pattern is. And that'll allow you to flush it with a pattern or a template bit on your router or shaper table. So when you end up, after you route it, now the pattern and the piece of MDF are flush. And now you're ready to make the rest of your pattern. And it's really important, as I'm sure you guys know, for any pattern, that you spend a lot of time making this right. Because any inconsistencies you have in the curve or the shape of this pattern are going to translate into the final lamination. That's the same as if you're shaping a cabriolet. If the pattern's not right and you shape to it, then you're going to end up with bumps or dips, and it's going to be visible. So it makes sense to spend a lot of time ensuring that your pattern is well done, so that when your final lamination is done, you won't feel those bumps and dips translated into the surface, because they will, and they'll be noticeable. And you don't want to have to go back later on and try and ferre those out, because you'll run the risk of shaping through your laminations. So after I've made the central part of the spine, I'm going to, I've got my two pieces of MDF that I have screwed together, just like these pieces here on the board. And I'm going to screw them onto my pattern. So that is the first half of the form. So now I'm going to take it over to the bandsaw, and I'm going to cut it close to the shape, to the form, and making sure that once again I don't cut into it, because if you cut into this, you're not going to be able to flush it on the shaper or the router table afterwards, and you're going to have to start over again. That's a bummer. So now I've cut it close, and I can put the second piece of the T on.
Are those just drywall screws?
Yep, I just use coarse drywall screws. And let's try that as well. I tend to use, as you can see, I tend to use a lot of them. Because there is some tendency for the, if you don't have it tightly screwed down, you could flex it out. So you want to make sure that it's secured properly.
Do you use glue between your MDF?
I don't. No. I use enough screws where I don't think it's necessary. You could, absolutely, and then probably make it stronger. But for me, it's not worth waiting the amount of time it would take to let that glue dry.
We want to let some fresh air in. Is everybody warm?
Yeah, it's pretty warm.
It's pretty warm in here.
Sleepy time, man.
No, it's just, it
No?
would be nice to flush.
Alex, what happens when you get your 7/8?
Alright. So now, this piece right here represents what I've done after bandsawing it. So this is the first piece you put on, and then you bandsaw it close, and then you can take it to the shaper or the router table. And if you have all you have is a router, it's too easy. Just get a top bearing flush trimming bit. You put this down on the surface, and then you flush it to your pattern, and then I just flip it over and go back. Safe, easy. And what I didn't mention before, I'm going to step back a second and talk about why I use MDF instead of plywood for my forms, because I think this is an important point. You can use either, but the reason that I like using MDF, well, there are several. First, there are no voids. So everybody knows these days with plywood, you get a piece of plywood, looks great on the edge, you cut into it, and you've got a 5-inch long section of just void. With these forms, you don't have, that's bad news, especially if it happens on the edge. You know, if you get your center form made perfectly, and you go to flush this edge, and then you realize that there's a huge void in the edge, then you've got to take that piece off and redo it. And that's a problem. And with the number of voids that you find in these pieces these days, it's bound to happen. So that's one reason. The other reason is that MDF doesn't have grain direction. So it's a lot easier to flip it over and flush it the other way when you don't have to worry about running uphill against, even though the plywood, you know, is interlaced, if you're running uphill against the plywood, you could easily tear a piece out. You know, they're so poorly bonded together these days, you could easily tear a piece out and then you have that void all over again. Whereas with MDF, because there's no grain direction, that's not going to happen. It's just powder. And then the third reason is that if you're going to add a twist, the grain direction becomes important again. And it'll do a number on your hand tools, but MDF you can shape any direction you want, and you don't have to worry about that grain direction. So I think it's a superior product for form construction, and it's cheaper than plywood. And it's uniform thickness. That's another important thing, is that especially when you're getting into, you may find yourself wanting to get a consistent thickness. That may be important. And MDF is much more consistent in thickness than plywood. So I think that it's better overall. So that's why I use it. You ask a question?
Yeah, if you want to build a form, say it's 6 inches or 8 inches wide, just build it out and you can have segments and
Yes.
repeating the same process that you just talked about.
Exactly, yeah, and if you're, as long as your flush turning bit is perpendicular to the surface and the blade is in line with the bearing, it won't be a problem. You'll just be able to flush and just go right down the pattern. And in that case, I would probably use 2 or 3 long pieces for the middle rather than just one. Because you're not gonna, it won't matter if there's an 1.5 inches in the middle where you can't put a clamp. And I'll show you how I make little cawls that would bridge that gap. But you'd want to have that rigidity in the form because you don't want to have this long thing sticking out and then you're putting clamps on and then it's twisting over. Because the weight of the clamps is a lot. You know, if you have 50 clamps on there and they each weigh 10 pounds, you got 500 pounds of metal on that thing, and if it falls over, it starts to twist, it can create a lot of torque and a lot of issues. But I would still make them the same way. The reason that I like making forms like this, even with bigger ones, is because I like clamping directly to the form. And the way that I clamp things, we're going to go over later, but basically I don't like using 2-part or single part cawls that, you know, which would be a mirror image of this that you would just be able to press on. The reason that I don't like using those is that if there's any inconsistencies in either one of those patterns, you're not going to get pressure on the area. Or if you don't have them aligned perfectly and it slips a little bit, or one of the plies slips, there's so many things that can go on that would prevent you from getting proper clamping pressure on the form. And so single part, you know, cawls on the other side worry me for those reasons, because I don't think, there's just too many things that can go wrong, and I don't want to have to do it again. So I like using a flexible cawl.
How wide is your lamination strip going to be?
So for this stem, which ends up being 2.5 inches at the base, or 2 3/8, I think is the final width. This is the form for it, and hold on a second, twist it around as you can see. The form was 3 inches wide, and I make the, so actually, I don't even know how to get this. This was one of my actual plies for this, so you can see how much wider it is. And that brings up a good point too. You never do any of your shaping before you do the lamination. So this stem is tapered, but the ply is not. And the reason that you don't do it beforehand, it might seem like a good idea, like, hey, it's really easy to work with this flat ply, I'll just bandsaw the taper in now and glue it up and finish it up later on. But you want as much excess as you can afford, because no matter how tight your forms are, or how well made your plies are, they're going to slip in the form. And if you cut through the grain lines, you're exposing areas that could splinter off as you make it. If you don't have pressure on them, as you taper it around. Because with a single piece, you know, I have long grain running the whole length. But now, if I've tapered it, now I've got little ends all the way down. And when you do that bend, they'll just splinter right off. So that's why you don't do any shaping beforehand. But you can see how much wider this piece is than the actual one. And for the base, it's even more extreme. This is one of the extra plies that I had for the base. And you can see that at the ends, it's 2.5 inches more. And in the middle, it's like 1/2 inch taller. than the actual form. But these things are a disaster to glue up. I mean, when you put them together, there's glue everywhere. You know, the plies all slip a little bit. You know, one ply slips an eighth of an inch one way, one slips an eighth of an inch the other way. All of a sudden, you've got a 1/4 inch difference that you have to, you know, make up for. So you want to give yourself as much extra material as possible. So we've talked about flush cutting, and we have made our T-shaped form now. And so now what I'm going to talk about is adding the twist. If you can see the end of the form from there, I had to incorporate the twist into the pattern. So you start off with your form, and it's a straight T, like that. But you want to add a twist now, because you need this reference surface to be parallel to the front, but this one is 15 degrees different. And that's another reason why you have to measure it, so that you know how much twist is in the shape. So the way that you do that is you go back to your original form, your original pattern. Did you ever do a pencil like a bar? So I don't do anything fancy to incorporate the twist into the form. All I know is that at the bottom here, I need to put a 15-degree angle into the form. So I take my bevel gauge and using my drawing, I put that angle in. And then I draw the angle here on the end of the form. So that's my finish point. That's where I need to get to. So on this little form here, we'll say that, for our last different pieces on this. Okay. So on the end of this form, I know that this is the starting point. So this is the side of the form that I am not going to change. All right? But here at the bottom, I know that I need my 15-degree angle in there. So I don't have a bevel gauge, but I'm just going to rough out my 15-degree line on the bottom. So that's your reference point. And your starting point on the top is wherever you want the twist to start. So on this piece, I started the twist just below the rest right here. And it's pretty simple. So let's say on this pattern, the twist is going to start right here at this line. Does everybody see that? All I do is I take my pattern, I line up the bottom of the pattern with my angle line, just like that. And then I line up the top of the pattern with the mark that I've made right there. Because essentially you're just transferring the same shape and you're just skewing it a little bit. So I connect those points on the form, and I know that this is the area now that I need to remove in order to twist this form. And that'll give you a continuous twist all the way down. And because you've used the same pattern for both sides, it will remain, you know, parallel, essentially. It'll look right. That's what matters. So at this point, you know that you have to remove this material and this material down to here to make that twist, to get it to look like this. And how you do that, there are no easy ways. For this one, I did a little creative band sign. Got it up on edge. I had some like wood blocks that I propped under it, and I just sort of took chunks out of it to get close. Because you can see that's a lot of material to move by hand. You know, I'm not going to spend hours with a hand plane like just working on MDF. So whether you use, you know, other options, you could use a belt sander, a handheld belt sander, maybe a handheld planer, electric planer. Whatever it takes to get most of that excess away. As long as you're careful not to touch this edge here that you want to leave. You don't want to shape into that because that's going to start affecting your shape. And you don't want to remove material below this line that you've drawn here. But just get as close as you can as you're comfortable with. And then you go to hand tools. And the reason that you have to use hand tools to finish this off is because with this twist, at any given point on the twist, the angle between this side and this side is different. So we start off here, where you started at 90 degrees, right? This point is 90 degrees. Down here it's 15. But in between, any given point is a little bit different. So you can't take it to a machine and just do it easily. It has to be done by hand. You have to remove material and get that angle to be correct at every point along the twist. And the most difficult part about doing that is that each part of the twist has to be flat. So if you look at this pattern, you put a straight edge down on it, here, here, all the way across, it should be flat, all the way up, even though the angle in relation to the side is different. The tendency is you remove most of your material, and then you're a little ways from this line, and you're like, all right, I'm going to hit this part of it and bring it down there. So you remove a bunch of material from this side, and now you're at your line here, and it looks good. You've reached your line down here, you've reached your line here, and you haven't touched this side. But what you've done is crown it. That's the natural tendency, is to crown it. Because you're going to chase this edge down to your line because you're afraid of shaping into this side, which you don't want to touch. So you just have to, it takes a while. I think it took 2.5 hours to get it so that when I laid a straight edge across at any given point on the form, that it was flat enough for me. And there's a little bit of, you know, that last 1/16 of an inch, does it need to be perfectly flat? Probably not. You know, if it dips a little bit, you're going to cut, that's going to be glue and mess. And so there are a couple places where, you know, it's not totally flat, but I just left it and went on.
Can you pick up the end with a red clamp, just pick that up in the air so we can see the curve as it goes back?
Yep. I'm pretty tall.
Wow.
So you can hopefully see.
Yep.
Yeah. Does that make sense to everybody?
Where does it become 90, where does it become flat?
Right here. So I needed it to be flat for the whole length of the flags.
Oh, so you're holding the top of the stand.
I am holding the top of the stand right now. Yes. It's flat right here because I needed all the flags to be parallel to each other. Because if the twist if I had kept the twist going all the way to the top, then the flags would have been twisted around if I tried to, and then I would have to try to join them at different angles, so then it would have been done. So yes, you can see that, and we'll, and if you want to come up afterwards and take a look at it, we can talk about it, that'd be great. So does anybody have any questions about the twist right now? Does that make sense? Okay. And for many things that you do with bent paper laminations, this isn't a step that you need to take. The form, the construction that we've already discussed, that'll be enough. So, all right, so now you've got your form done. It looks like this, and you're ready to make your laminations, or your plies, I'm sorry. So what you start off with is a blank that looks like this. So for this piece, I used a piece of 16-quarter walnut. It turned out to be quarter sawn, or I'm sorry, completely flat sawn, which gave me a quartered edge and a totally flat sawn face. And that's fine. The most important thing is that you get the most consistent, straight grain, void free. You don't want you don't want figure if you can avoid it, because figure is, you know, waviness in the grain. So if you've ever tried bending tiger maple before, you bend it, just snaps right at the any of the curl, because that curl is the grain popping out of the surface and then going back down, and that the difference in reflection is what gives it its figure. But it makes it terrible for bending. Now you can use it, and if the bends aren't too severe and the pieces are thin enough, it won't be a problem. But if you're doing really extreme bends, like the base of this music stand, where you need, you know, pieces to bend around a 17-inch curve, you need to have the best material you can get, because if there are any defects, if there's any run out in the grain, it'll be very prone to breaking. That being said, there's plenty of good walnut, cherry, maple around, and that's why I like using domestic hardwoods, because you have a lot of choices, and you can whether if you go to the lumberyard and you pick through the bin, you can find a piece there and it's going to work well, and which is one of the reasons why I like using this material.
So that is kiln dried?
This is kiln dried. For bent paper laminations, it doesn't matter whether it's kiln dried or air dried, because you're, you know, steaming, air dried can work better, and probably for bent paper laminations, air dried would work better too, because it still maintains that elasticity that gets, you know, sort of cooked out of it when you kiln dry it. But I think it's more important that you cut it thin enough that it'll conform to the form readily, rather than relying on its bending properties to get it around. So this is the blank that you start off with, and the way that you prep this blank to start cutting the plies out is pretty straightforward. It's just like anything else. So you take it over to the joiner, and you joint one face, and then, you know, you flip that face on edge, and you get a 90-degree, right, general standard milling. Take it over to the planer and run that first face through again. So now you have one edge that's been jointed, and you have two faces that have been, one has been jointed and one has been planed parallel. Now you're ready to cut your plies out. Don't worry about the last edge. You're going to want all the material that you can get, and there's no reason to plane or saw off that other edge. That's just going to be your the outside edge as you cut the plies. And I find it really helpful to have a rough edge as a reference, because once you start cutting this and this piece is getting smaller and smaller. At some point, it's going to end up as a square. And if you have, let's say, we run it through like this, and this place is flat. Well, now it's a square. And if you've jointed and planed every edge, it's really easy to lose track of what side am I cutting now. And you pull out of the planer, you twist it around, you go back, you cut a couple more plies, and all of a sudden you realize that your first 10 plies were cut with the board held like this, and your last 5 were cut with the board held like this, and you put them together and they look totally different, because the light reflects things differently. That's a pretty bad feeling, because now, is that good enough for you? You just start over again. Exactly. So I like leaving that last edge rough, and that gives you, all right, I know this is always the edge that's parallel to the fence. So you've jointed and you plane them, and then you set up your bandsaw so that you are going to cut off a piece that is however thick you want your ply to be. So on the stem of the music stand here, my finished ply at the thickest part was 1/4 inch. So when I cut these plies on the bandsaw, I think I cut a 30-second over. That was my goal. You want to leave extra, but you want to leave as little extra as possible, because you're trying to get as many plies out of this board as possible, so that you have a lot of extras. I used 8 plies in the stem lamination, and if I picked up my board and I cut out 8 plies and thought that when I got to there, those 8 plies would be good to go, then I'm taking a big chance. So as you can see, I have 2 extra plies with me, and I think I had 4 total. Because when you're running pieces like this through the planer, run a 16th inch piece through the planer and see what happens. The ends of these things get very thin, and this piece you can see here is about 1/8 of an inch thick, but there was 6 inches extra on both ends when I ran them through the planer that tapered down to almost a 16th, because they explode, they crack. The pressure from the in-feed roller, the pressure bar, the cutter head hitting it, they shatter, they break, they split. So you want to give yourself plenty of extra plies, because if that split, if it just shears it right off, if you've got any run up, it could just shear off the last foot of the lamination. You need to have extra in case that happens.
You don't use a drum sander for the final package?
I don't, because I don't have one. So, actually, the machines that I really like are, that I think work really well, are the little, if you have a helical head planer, you'll probably be great. That's awesome. Honestly, for your money, those little like lunchbox planers with the router motors, like the DeWalt DW735 or whatever, they cost like $500 new.
One right there.
Yeah, like one of those.
Good for printing stuff.
Yeah, they don't have, the reason that they're nice is they don't have bed rollers. They've just got a solid platen that runs through, so you don't have the pressure from the bed rollers pushing the sled up into the cutter, because even that 2/1000th of an inch can be enough to create a problem, and they spin so much faster than a normal planer. I can't remember what the RPM is, but it's like 11,000 or something.
Yeah, something like that, right?
Versus 3,000 or 1,700 for a normal planer.
You could use a Performax with an 80-grit belt with a sled. Works pretty well down to probably about 15,000ths.
Yeah, you could definitely use a sander, and that's a little bit safer. You're still going to have issues with snipe at the ends as it comes off.
Yeah, they'll burn though. That's why I say don't go any less than 15,000ths on that really thin stuff.
Yeah. No, absolutely, and that's totally, if you have it available, that could be a great option as long as it works well. One of the nice things about the planers, so that you don't have to worry about any runoff off the edges, because there's no squishiness of the blades. It's going to be totally parallel to the other side. So, you know, those little planers, they work great because the blade speed is so high that you can take off. You're taking off so little material with each rotation of the knife that they're just not exerting the same pressure as if you put it through that Whitney and you're taking off, you know, that Whitney right there, you take off a 16th of an inch at a pass, and you know that thing's just like bam, bam, hammering into it. So I think that those things work really well, but a belt sander would work really well as well. So you start off and you make your first pass over the bandsaw, and you end up with a ply like this that is not tapered, right? So the whole thing is a little over 1/4 inch thick. You put that off to the side, and you mark it as number 1 on a side that you choose. Whether you mark it on the jointed face or the bandsaw face, it doesn't matter, as long as you're consistent on each one. So I take my ply, and I write number 1 on it, and then I set it off to the side of the table. And now I take my blank and I go back to the joiner, and I make another pass, and I ensure that this side is perpendicular to the side that's sitting on the surface of the bandsaw. Okay? And the reason that I do that, the reason that I don't just, you know, you make that first pass, you could just go right back through over and over again. But you guys know, once you make 2 or 3 passes with a bandsaw, that edge is not going to be flat anymore. And you're also, now you've got the same problem that you have when you start off with this blank. If you have 2 faces that are bandsawed, it's pretty easy to flip one of them over, so that now your plies are out of order, and when you glue them up, you're going to notice like a different colored line running through your lamination. And the goal of bend tapered lamination is to make them look like solid wood. If you do it carefully and the joints are tight, and when you glue it up, you know, afterwards come and look up at the stem of this and try and find the glue lines. If you keep them in order and you're very careful about marking everything as you go through, when you glue it back together, it'll look like solid wood. And that's the goal. So I make another pass, and I get my second ply. I write number 2 on it, and I put it on my pile. And then all I do is I walk back and forth. I go over to the joiner. I make another pass. I flatten that face. I come back to the bandsaw. You know, I usually just leave both machines running. And if you got the power in your shop to do it, make a pass, cut out a ply, mark down number 3, put it on my pile, and just go back and forth till you get to the end of your blank. And now at this point, ideally you've got 4, 5, 10 extra plies. And you have your pile in order, so that when you hold it up and you push all the pieces together, they look, you know, just like this board does right now, where you can see all the grain lines and they're all parallel, and it looks as tight as you can get it. And you have one face that is jointed, and you have one face that is bandsaw. And that jointed face, you aren't going to touch again. If you're careful with the milling, that's ready for glue up. And all the remaining tapering is going to be done to the face that you bandsawed. And one of the reasons that you only taper one side, I mean, theoretically, you could put it on your sled, you run it through, and then you flip it over. You know, and now instead of having like a 90-degree triangle where you've got your jointed edge that is perpendicular to the bottom, now you've got an isosceles triangle where they both taper the same amount. But what happens there is that you're cutting away a lot of your long grain, and you're losing your reference face. So if you leave your jointed edge, boom, it's done. You have it marked off with the number, you're not touching it again. Now you just run that bandsaw face through the planer over and over again when we do the tapering. then you only have one face that has the long fibers cut into it, ideally. And then the rest of it is the long fibers are running the full length. Whereas with the other side, you're going to have ends all the way up as you cut into each one. And that's, I'm assuming that your long grain is perfectly parallel to the blade in the first place, and we all know that's probably not completely true, but it's a lot easier to work with it if you finish that jointed side, it's done, and you do all the rest of the work with that bandsaw side.
I know that you probably have tried it. Have you tried just gluing up a flitch of veneer?
I have not yet. No, I thought about doing it.
You thought about it?
Yeah, like if you get the 16th or the 8th inch veneers, you probably could.
You have a little more control of grain here with direction than you would buying a flitch like that.
You do, and it's a lot. It can get pretty expensive the way veneer runs per foot to get that much veneer. But you could definitely, if it's cut well enough, you could absolutely do it.
They tend to cup a little sometimes.
Yeah, sure.
You get that.
Mm-hmm.
The other thing you can do is, if you don't want to do all that numbering, what I do is at the end of my blank acrylic paint, just put one line right down, and then you can always match it up.
Yeah, absolutely, and I do that too. I draw like a big V on the end, so that you know that when you put it back together, you'll be able to see the V on the end. That's a great suggestion.
Different colors for different flitches if you're doing that.
Yeah, and that way, whatever side you're looking at, you're going to have a reference mark. So I do it on the sides as well. Like put a big V in, so if you're looking at the side, you know that they're in the right order. If you're looking at the end, you know they're in the right order. Because when you get them on the form, you may not be able to see your mark. Some glue squeezes out, all of a sudden you can't see it. If you have multiple places where it's referenced, then whatever edge you're looking at, you'll know. So at this point, I have cut out my plies, and they are uniform in thickness. So they're 1/4 inch at one end, 1/4 inch at the other end. And for a lot of applications, you don't, at this point all you have to do is run them through a thickness planer or a sander to your final thickness. If you're doing the aprons for a demi-room table and you want it to be a lamination rather than brick laid, leave them at that thickness and then you just glue them all back together around the form. If you're doing curved moldings, if you are doing, I'm trying to think of other examples. Those are the two that spring to mind. If you're doing stretchers that are curved, you don't need them to be tapered. Then at this point, you don't need to make a tapering slide. You just run them through the planer so that you remove those bandsaw marks and you get a pretty smooth surface, and you're ready to do your lamination on your form that you've made. But if you're using the plies and you're going to taper them, the next step is to create a taper sled. And that is what sorry about that. So this is a taper sled. I'll bring it up here and stand up for a sec. If you can see, the taper is not very significant. What I have written on the side here. So the slope is from 3/16 to 3/32 of an inch over 27 inches. And this is what you're going to run through the planer. And now we're going to talk about how you make these tapering sleds, because this is one of the most important steps of this process. And the reason I say that is in this base, I used 14 plies for the lamination. And it tapers from 2 inches in the middle to 1 inch at the ends, which means that each one of those 14 pieces tapers from an eighth to from a quarter to an eighth, let's say. But any error that you make in the taper is going to be multiplied by the number of plies that you use. So let's say that you use, for ease, this one is, I use 8 plies on the stem. And they're tapered from a quarter of an inch to an eighth of an inch. Same thing. Let's say that I'm off by a 32nd of an inch. And I have 8 plies. So instead of tapering from a quarter of an inch to an eighth of an inch, they taper from a quarter of an inch to 3/32 of an inch. That mistake is multiplied by 8. So instead of it being, a 32nd of an inch thinner than you wanted it to, now it's a quarter of an inch thinner than you wanted it to be. And if you're going down to pretty fine dimensions, you could end up with nothing. So it pays to be really careful when you make these taper sleds, because any mistake that you made is going to increase pretty dramatically. So it's tricky. So we're going to talk about now how you make these taper sleds.
How close does it need to be?
It depends on how many plies you use. If you have, for this, I had to be within for the base, I wanted to be within a 64th, because they were a quart, they're 14 plies, so 64th, 14 64ths is, almost, 7/32. So we're getting close to a quarter of an inch. I mean, eighth of an inch, right? You're getting close to an eighth of an inch difference, which is as close as but 64th is pretty close. It's pretty tight. Whereas on other ones, if you have a giant table leg and you make it out of 8 laminations, and you're within a 32nd, then you're probably not going to notice a quarter inch difference if the table leg is 6 inches thick at the top. So it just depends on the scale and the number of plies you're using. But I just try to be as accurate as I can be.
Once you've done the work of making this tapering sled, do you now try to incorporate that taper in some of your future projects, so you don't have to go back and repeat the process?
You could. You definitely could, especially if it was like a table leg. Right. The pictures that I showed earlier, the table up there on the right that was built by Jerry Osgood, I know that Jerry had a series of sleds, and he used, the same leg on a lot of things, very similar shaped legs on a lot of things. And for a professional, it makes total sense, because, it takes a lot of work to make the forms, the sleds, all the patterns. So if you can reuse that thing over and over again, I think there's a saying, like, you never make money on the first form, you always make it on the second time you use it. So there's certainly incentive to do it, because I think half of this project was building the patterns, the sleds, the forms. It takes a long time, and you have to be really careful doing it.
You lost me somewhere along the way.
Okay.
You're going to taper those before you glue them up.
Absolutely.
Why don't you glue them up as a square and saw them after?
Good question, and there's an important reason. That is, if you glue them up square and you then cut them to their shape, you're going to have to cut through each one of the laminations, and that will show up as this ugly glue line in the pieces, and like a line straight across the piece. So if I had
like a scarf joint where it's exposed layers.
Yeah, it would look like a scarf, but when you're using epoxy and Unibond, they're sort of going to seep in, so it's not just going to be a pretty line, it's going to be this big, like, irregular blob of glue that comes through. So if I had shaped this and shaped through the front of each one of these laminations, you'd see like a cathedral line across with like this big, like, ugly dark brown glue blob at each place. rather than seeing just a continuous material.
All right.
And we're going to talk about that at the end when we talk about shaping. Because the reason that you have to be so careful tapering these is because you want to avoid shaping through the face of the laminations. So when you glue this thing up, you're going to have these pieces, right? And they're going to be all stacked up. And you're going to glue them all together. So now you're going to have this is the face, and this is the edge, where, another one, good reference. So this is the edge, and this is the face. When you glue them all together, you can shape through the edge as much as you want, because at this point, no matter how far you shape into this, all you're going to see is this thin glue line right here. But if you shape through the face, you cut through the face, you're going to end up with something like this, where you're going to have these steps, and there's just going to be like ugly glue smear. You know when you, if you glue something up and you have some squeeze out, and you don't clean it up properly, and you go to put finish on it, and there's that light spot, you know, around the edges of a Morrison tenon or anything that you put together. If you get glue on the surface, it can prevent the finish from, you know, sort of penetrating and darkening the wood like the rest of it. And that's what's going to happen. You're just going to have these ugly lines going straight across, and you're going to have glue smear over each one, and it'll look like a step going up. So that's why the taper is important.
Thank you.
Yeah. And we'll talk about that a little bit more at the end, if you have any more questions. So we'll go back to making sleds. Okay. So the taper. The taper is pretty straightforward. I have an example in the handout. Basically, off your drawing, you have to decide how many plies you're going to use, and then how thick they're going to be at the bottom, and how thick they're going to be at the top. And the taper is simply the length of your ply, whatever the finished ply is going to be in the stand. You're going to want to have, you know, I aim to have 6 inches extra on both ends when I do the tapering, because we'll talk about that when we're talking about putting it through the planer. So it's just the finished length of the ply and the difference in the thickness between one end and the other. So here, it's 1/4 inch thick on one end, and it's an 1/8 inch thick on the other, because I know that I want the stem to be 2 inches thick at the bottom and 1 inch thick at the top. And then, as you can see on the board, I take, this is my mini mock-up taper sled. There's a tiny piece of MDF floating around. That's fine, we can do that. Just talk through it. Okay. So, all I do is I start off with a piece of MDF that's going to be, you know, I decided that my sled is this long. So I start off with one of those. No, that's fine. I start off with a piece that's this long, and on it I start off at this corner, I measure down 50 inches, and then I measure into the sled 1/8 of an inch. I make a little dot. And then all I do is with the straight edge, I connect those points, and I draw the line onto the side of my MDF pattern. So now you've drawn the taper onto your the size of your taper sled. Okay? Do you have an L fence, Scott?
An L fence?
Okay.
My fence has two different finish heights. You can have up for flat height, or you drop it down to just a very...
No.
Something different.
Yeah, I meant to bring it, I forgot.
Talking about one that you tip 90 degrees.
No, it's an extension that you screw onto the fence. And I'll show it here in a second. Before I get ahead of myself. In this taper sled, it's essentially a torsion box construction. So you can see on the ends here that there are 4 ribs on the inside of the sled. And that prevents the deck from sagging when you put it through the planer. It makes it really rigid, and it prevents it from warping as it goes through. The number of ribs that you use is dependent on how wide your laminations are. I made this so that I could put 2 of the plies on at the same time. You could do it so you did 1, you could do it so you did 4. You just need an appropriate number of ribs. So it's totally determined on how big the sled is, or how wide, and what how long it is, so on. So for my little demo sled, I'm using 3 ribs. So all I did was I started off by placing these 3 rectangular pieces of MDF on the flattest surface I could find. And maybe that's your jointer or your table saw, ideally it's your jointer. And then I clamp them together so that the bottom edges are as close to being, parallel and in the same plane as possible. I clamp them together, and then I screw them together into a bundle. On the outside piece, I have my taper marked off. And the way that I cut the taper now is that I go to the table saw, which is hidden. So I'm going to try and mock this up. Okay. We'll use this. So the first thing I do is I'm going to take my bundle to the bandsaw. And I'm going to bandsaw close to the taper line that I have drawn in there, right? So that it'll end up that you'll have a 1/16 of an inch extra on the outside of the line. But now you need to ensure that these pieces, you need to get a continuous surface so that these pieces are all exactly the same. And the way that I do that is on the table saw. And what I do is I take what I am calling an L fence to the table saw, and I use clamps to clamp it onto the fence. So let's pretend for a second that this is the table saw fence. I clamp this L fence on above the height of the table so that now my bundle can pass underneath it. Okay? Does that make sense to people right now? I'm sorry that I don't have a better, this is something that I'm missing. So all it is clamped, and this edge of the fence is parallel to the fence, but it's raised up off the surface of the table so that I can slide the bundle underneath. But you want it just above the height, because what you do is, once this is clamped in place, I am going to take a jointed piece of hardwood that has one totally straight edge. And I'm going to face one side of it with pressure-sensitive sandpaper. You could use adhesive, it just makes it more difficult later on. This is a really quick operation. The reason I put sandpaper on is because it'll grip the surface of the bundle. And what I do is I take this straight edge and I line it up. On the bundle with the taper line that I have drawn. Okay? On the table saw, in the meantime, I have adjusted this L fence, which is clamped to the fence, but it's raised up above the level, so that the edge of it is in line with the outer edge of the blade. So that when you're going to reference this piece, this board, against the L fence, just like this. And you're going to push it through. And you'll be able to cut the taper in safely. Because you bandsaw it close, so it's going to be a dust cut. There'll be nothing on the far side to fall in between the blade. But there's space under the L fence, so that you're not running the blade into the fence.
And that's like using a rotor, right?
Yeah.
What do you call it?
Yeah.
Yeah.
The part that he's putting on the sled is just a bearing, straight edge. It's just a straight edge bearing. It's going to ride, the L fence is just an extension of the regular fence over the blade and come, but gives enough clearance for the workpiece to go on.
Yeah, should we screw that down onto those?
I do not. That's why I put the sandpaper down, because the sandpaper will grip it, and you're pushing it down, and then you're removing as little material as possible, so there's not going to be a lot of resistance, especially with MDF.
If you screwed it down, it wouldn't matter though, right? It gives you
You could, yeah, you absolutely could. Yeah, it would be, and it'd be more security. The reason that sometimes you have to make multiple cuts, like you can use this for a lot of different techniques, this L-fence technique. So I just have one in my shop sitting around. You can use it for tapering legs and for creating jigs that have a straight face and a taper in it. They're used for a lot of different things.
Tool addition or something on the other.
They had nothing to there.
Recently.
Yeah, okay. Then I would definitely look that up because it'll give a better explanation than what I just gave here.
This is a lot more accurate than just using a tapering jig that
You could use a tapering jig.
Too short.
This is, yeah, it might be too short. You can make a longer one. The nice thing about this is that I just have it laying around, so I don't have to do any extra work. You don't have to make another fixture to run these through. All you do is you take your board that has the straight edge, you place it down on the line, and then you push it through with the L-fence. And it takes 5 minutes to set up, and then you take it off in 10 seconds, and you're ready to go back to whatever else you're doing. But there are definitely other ways that you could do it, and if you wanted to use like a purpose-built taper jig, you could do that as well, and that would be fine. So at this point, you obviously want to double check that the blade is perpendicular to the table. You've made your cut through, so now these pieces the bottoms are all on the same plane, and the tops all have the exact same taper. The last step that I do to these is that I cut a curve, a reference curve in the bottom. So can everybody see the curve here? And the reason that I do that is that when I make the top and bottom, these are going to be the top and bottom of the sled. This is the top, and this is the bottom. And in the bottom, at the same time that you cut this curve, you just use the same setup, and you cut a curve in the top of the base, so that when you put them together, I use a little spline that I found. This just happens to be masonite. You put that spline in to the kerf like that, and when you take the bundle apart and you put them into these, they line up with the spline, and that ensures that each one of these ribs, after you've separated them, is at the exact same point in relation to the other ones. If you don't have this spline and you're trying to use the end of the board or some reference, it's very difficult. You know, you start drilling and the drill pulls it a little bit or something. If these ribs get misaligned, then, you know, the whole purpose that you were trying to get of having a flat torsion box has been defeated, because now when you slip one of these, it either creates a bulge or a dip, and you're not going to get the proper result. So I take my bundle, going back to the construction, I put that to the side, and now all I do is I take my base, and the top and bottom, they're simple. It's just a rectangular piece of MDF. I cut them out the same size. I don't worry about any differences in length. And I just run one over the table saw and cut grooves to put the ribs in, so that they just have a way of ensuring. I cut the grooves in so that you know that they're parallel to the edge. Theoretically, you don't have to do it, but if you twist them so that they're not parallel to each other, then you have to worry about the same thing, getting a dip or a bulge in the pattern. So just get your dado stack set up, and one of the nice things about using MDF too versus plywood is that MDF is like generally right on 3/4 of an inch, and your dado stacks are set up to cut 3/4 of an inch, whereas plywood can be anywhere close to, you know, 11/16. But any given sheet of plywood is going to be a range of thicknesses in there, and maybe you've got it set up so that it works on one sheet of plywood, but you go and then it's loose and it's sloppy. I don't like that, so it's going to get.
Question, why can't you make this, rather than using a torsion box, out of 1 inch or 1 1/4 inch MDF?
What, I'm sorry, I don't.
Thicker MDF, whatever thickness you need, and just run the taper on it, on the table saw without having to make up the torsion box.
It's not going to be as rigid. If you have a piece of MDF that's six feet long and it's only 1 inch thick, you're gonna be able to bend it. You know, I can take a. Yeah, it does matter, because when you put it through, you don't.
Torsion.
I mean, theoretically, I'm trying to work this through in my head.
Well, you're trying to prevent the planer bars from making it go.
Yeah. I think there's more room for error. I can't tell you off the top of my head why it couldn't work. I don't think it's going to be as precise, and it's also more likely that, like, when you put it in, maybe the biggest problem is that, I mean, not many of us have 20-inch table saw blades where we can run 6 inches perpendicular to the blade. You know, if you have a 10-inch saw and your max capacity is 3 inches, you know, that's the biggest problem. But I mean, theoretically, if you had like a board, I suppose you could do it. So now I've cut my grooves, I've cut my and now now I take the bundle apart, just breaks apart into 3 ribs, and I take the ribs and I slot them over into the grooves. And now you've got the first part of your torsion box. And all you have to do at this point is put the deck on and screw it together.
Again, you don't do it, just screw it together.
I just screw it together. Theoretically, you could use glue. I just use a lot of screws because once again, it's just a time issue. You're going to use the screws anyways because I don't think that the glue, especially, I like the mechanical advantage. I think that you could glue it as well as screw it. I would not just screw it together. I would not just glue it together.
No, that's right.
Yeah, because it's going to take a long time. You have to wait a couple hours for it to fully set, probably overnight. You know, if I was going to run it through the planer, I would wait overnight if I just glued it. So I would just rather screw it. So then you basically make sure that the ribs are, you know, perpendicular, and you screw it together. And I put a little stop on the bottom, and you're good to go. So that is the taper sled. And now,
Question. When you put the stop on the end, that's the lead edge.
it is the lead edge.
It is the lead edge when
Yeah.
you're putting it through.
Yep. Yeah, and
And is that sort of a gauge for the max thickness, or can you use that for?
theoretically, if the taper was really small, you would want to use, you don't want to cut into the stop. So if the taper is, if one end is thinner than 1/4 of an inch, then you definitely need to use something else. So you don't want to cut into the stop. So it should, you know, be, but it doesn't have to be thicker than 1/4 of an inch. You know, if your ply is 1/2 inch thick, it doesn't have to be 1/2 inch thick. I just use it so that it doesn't get pulled off the sled, you know. Because theoretically, if you put the sled in and the in-feed roller caught the ply without a stop there, it could just pull the ply right off the sled. So this stop just ensures that everything stays together as it goes through the planer.
So your final cut, were you cutting the entire length of the ply?
You are.
You are.
Yeah.
And you may have an application where you're not.
You do, if you're doing a double taper. So the stem on this is a single taper. So these, you know, these ones are 1/4 inch thick at one end and 1/8 of an inch at the other. But on the base, it is a double offset taper. So because the thickest part of the base is not in the middle, it's in line with this. One leg is like 6 inches longer than the other one, I think. So you can see that this goes down to a 1/16 of an inch, and this goes down to a 1/16 of an
Yeah,
inch.
cool.
But the center point is not in the middle, you know, of this. It's offset 6 inches. So the taper is different for each side. So you need to, you taper like half of it, and then you put it on another sled, and you flip around and taper the other parts.
Do you by any chance dream in angles?
I dream in curves. I just use angles to make them. Yeah, so the double taper is exactly the same thing. That's what we're talking about. It's just that it starts at a different point. Okay. Yeah. So the last two parts, I think I can go through relatively quickly. The next,
I'm sorry, did you say the stop is on the front edge?
it's on the front edge, yeah.
Isn't that, as you put it through the planer, isn't that gonna shoot the piece out the backside of the planer?
No, when you
It's
put
nothing to hold it in place. Gonna shoot it out the back?
No, the stop is there to prevent that from happening.
So the way it's determined
the blades are turning against you.
Right, but you put it in so that the, yeah, I should have made this
The
clear.
rollers are dragging you through.
You put the thin end of the taper sled in first. So it's cutting uphill as you go through. So the thickest end of the ply goes in first. And you cut more as you go through. So you are going to cut with each pass. When you make your first pass with this taper sled, you put the ply on. You put the ply in, this is not the proper sled. It's a 1/4 inch thick at that end, it's a 1/4 inch thick. You pass it through the planer. You're only going to cut 6 inches here. You know, when I make my passes, I take maybe 64th with each pass, because these pieces are so fragile. And then I cut all the pieces at once, and each one of them only cuts this last 6 inches. And then you raise, you know, either raise or lower the head a 64th of an inch, and you make another pass, and it cuts another 6 inches farther down. So now you've cut a foot, and you just work your way down. And because you're cutting uphill, the pressure of the in-feed roller and the pressure bar against the sled prevents these from being chucked back at you. It's essentially, it's no different than just putting a piece through the planer, right? Because if you're using one of those little lunchbox planers, it doesn't have bed rollers either. So the only thing that is preventing that piece from being thrown out of the planer, if you don't have bed rollers, is the in-feed roller and the out-feed roller.
Pushing down on the bed.
What's that?
Pushing down on the bed.
Pushing down on the bed and holding it against the bed. And they drive it through. The in-feed roller drives it through, and there's enough pressure to prevent it from getting kicked out. This sled is no different. The only difference is that you've changed the relationship of the bed to the cutter head. So the bed is tapered rather than being the flat surface of it.
You said you run 2 at a time through there. Do you do anything to keep them from kind of...
Yeah, you can see on the edge here I have an edge guide.
Okay.
And I just keep those to prevent them from twisting off.
One on each side? Or just...
Yeah, they broke off this side. I didn't even clamp them down. I just tacked it down, and, you know, with finger pressure, and did as quickly as I could. So it doesn't really matter. They don't have to be anything special.
Now, when your glue up is finished, this 15-degree tapered end is going to be stepped
It is.
on both sides.
It is. We'll talk about that when we get to shaping.
Just visualizing it.
Yeah, no problem. So, in order to do the tapers, like I just talked about, you start off with the thick end of the ply or the thin end of the taper sled running through first, the end that the stop's on, and you just run it through over and over again until you get down to your finished thickness. It's really time consuming. You want to do all the plies at the same time, so you make one pass with all the plies, and then you change the adjustment, and then you make another pass, and another pass, and another pass. And I think it took me 2 hours to do all of the plies all the way down to their finished thickness on all 3 sleds, just because these things are so thin that you need to go really slowly, or else no matter what you do, you're going to have snipe and the ends are just going to explode. So that's why I have a couple inches extra.
There's a reason why you wouldn't want to use the sander doing that, thinking about it. And that is after every pass you'd have to mic it, because it wouldn't be exactly the same. You'd get it there, but it'd probably take you a little longer to get there. It's safer, but it'd take you a little longer. Right, you got to mic it after each one.
Okay.
It's not the same.
Yeah.
It'll be fine from edge to edge, but you still got to.
Okay. Yeah. So once you've done the tapering process, and it's just time consuming, you end up with your plies, and at this point, you lop off the ends. You know, as I said earlier, I try to have 6 inches extra at both ends, and that ensures that when you put them through the planer, that if there's any snipe at the beginning or the end, you can cut that off, because the snipe will be really severe on these, and when you glue them together, you're going to see a little scallop going all the way through. So you want to be able to cut that off. So now I've cut them to my semi-finished length.
Where you leave the studs? You're talking about the double taper, like when you're like down.
Yeah.
And you have a different sled for each end because of the different taper. Okay, so you run one of them through and you're working it down, and just to put a mark across it so you know when you've gotten to that point.
Yep.
You turn it around, and of course the same mark you put it through.
Yep, absolutely. Yep. Right. So now you have you tapered all the pieces, and you're ready for the glue up. And the glue up can be really easy, or it can be a total disaster. And the biggest thing is preparation. You want to make sure that you have everything ready to go before you start mixing glue. And I'm gonna sort of go over this relatively quickly because it's not very complicated. All I use for the cawls on the top of the plies are a stack of masonite. So I have my one piece of masonite here that is going to be on top of the plies, and I face that with clear packing tape. Many of you may be familiar with waxing forms to prevent things from sticking. I don't think that waxing works very well. The amount of force that you exert with these clamps, unless you just have puddles of wax, is going to stick. So I find that I use wax on the sides of the forms, but on the faces of the forms I use clear packing tape, and that will prevent things from sticking. You won't have any problem, no matter how hard it's clamped, because the glue just will not adhere to the packing tape. And
You don't need to wax the packing tape at all.
no, you don't need it. It's so slippery. Everything will come right off. It works really well. The only sticking that you may have is glue dripping over the edges of the forms, and then all you have to do is just chip that off. Go ahead.
I was just wondering with the packing tape, do you have to, if you need a width that's wider than the tape, do you have to seam the tape?
I just overlap
together? You overlap them?
Yeah, I mean, I try to do as little as possible.
Yep.
But I just overlap them.
Okay.
It's so small, a couple thousandths. It's not going to make a difference if your form is good. And then you want to use as many layers. The thickest piece you can that'll follow the curve, and several layers, because you use these cawls to distribute the force from the clamps. So these strips, you can't have a clamp on every single piece of the lamination. So you want to be able to distribute the force from each clamp over as much of the surface as possible. It's never going to be perfect, but the thing I like about masonite is its uniform thickness, it's stiff, it's strong, and it's very hard. So you're not going to compress it with the clamps. And you know, I make multiple layers, as many as you need, whether you use 1/4 inch or 1/8 inch, it depends on the shape.
Do you soak your slots before you, so they'll bend easier, or do you do it dry?
I do it dry with at least, you need to try it dry with these, and then I try it dry with a couple of the extra pieces that I have. And you may need to make a test piece first to get a sense of how thin it has to be to follow the curve. So for like a curve on this stem right here, that's a really easy bend. It does not require a lot of force to get the plies to follow that. On the base, it's a different story. That's such a tight curve. To get them to wrap around that little radius, I had to make a couple test strips to see how thin I had to make it, because 14 plies exerts a considerable amount of resistance to the clamps. So you do have to use test pieces just to check. And the tighter the curve is, the more careful you have to be, because you may find that you can't get around. And you may be able to get like 2 or 3 around, but if you have 10, if it's really hard to get 2 or 3 plies around the curve, then you probably need to cut them thinner if you're planning to use 10, because your clamps just might not be able to do it. Like any given ply might make it, but the sum total of all their resistance, you might not be able to overcome.
You're talking about several layers of that, you're talking 3, 5, 8?
Yeah, I generally use 4 or 5, and I just stack them on top. The nice thing about multiple layers is too that they slip over each other. So if you have like one really thick one and you can get it to follow the curve, it's not going to slip. So it's more prone to breaking, and it's not going to distribute the pressure as well. Whereas multiple ones will slip over each other, because the radius is slightly different, and they exert more pressure. And because masonite's so stiff, it'll distribute the pressure pretty well. And so as you can see from this picture on the board, that's what it looks like. And I just use little hardwood cawls that go across every 2 inches or so. And I have, the reason that I use this T-shaped form is that when I put it on top, and pretend the other leg is here now I can have a clamp on each side, and I have a cawl bridging the middle that I'm not touching, exerting pressure downwards. And as you can see from the picture on the board, you need a lot of them. But if you have everything set up, and get someone to help you, because it's a lot easier with 2 people. It can go really fast. You glue it up, you spread the glue on each one of the pieces, making sure that you keep them in order. I just make a stack, and I apply glue, flip it over, apply glue, flip it over to all the faces, and then you put it on. That stack, one trick that I do is that I wrap the stretch plastic wrap around the middle of the bundle. So I have my 2, however number plies. I've got all the glue on them. Before I put them onto the form, I just take that clear plastic stretch wrap. It comes with a little handle on it. People use it for wrapping up furniture all the time. Put 2 or 3 wraps around it, and that'll help prevent the plies from slipping, and they'll hold them together. You're going to put it down on the form like this. You put it down on the form, and you start clamping, and you don't want them sliding this way or twisting apart. And just a couple, 2, 3 wraps of plastic wrap. It's not going to affect the final lamination. Any of that stuff is so thin that if you do it neatly, it's not going to add any thickness that's important. But it's really helpful to keep it together. And then you glue it up. You clamp everything down. And with Unibond and epoxy, the 2 that I mentioned, you have generally anywhere from 20 to 40 minutes to get that clamped up. And if you have someone helping you, and you've got everything laid out ahead of time, you have all your clamps ready in place beside the form, you have your little your cawl ready, and I just double stick tape these little blocks down on top. I have it laying right beside the form, so I put my bundle on top, I pick this up and I put it right on top of that, and then I start clamping. And if you have someone helping you, and the plies are the right thickness, you won't have any trouble getting it together quickly.
You work from the center out?
I do, yeah, for curved things. I think that's the best way to ensure that whatever, you're going to get some slippage in between layers because of the difference, that it's even on both ends. You don't want to start on one end. Plus, I think it's a little bit easier just to work both ways so that you know that you have the right length. I like to make a mark right in the center where I know that I want the center of it to be, and then I just line that up with a mark on the form. So for my round form, I have my center mark here and here, and I just have a mark on the bundle, and I just slide it right down in here, and I line that up with the line, and then I know that as I clamp around, the ends are going to be in the right positions. And then once you get it all clamped up, you let it sit. And I like to let it sit for at least 2 days. When you read the instructions on Unibond, it says will fully cure in 24 hours. every time I mix up Unibond, I don't care how warm it is, after 24 hours, you pull that leftover out of the little jar or the the rolling thing that I use, and it's always a little rubbery. And if you wait another 24 hours, it's like glass. And if you pull the epoxy or the Unibond out, and you feel that it still has a plastic quality to it, that means that it's not fully set, because they're not evaporative glues like PVA. They're reactive. So you need that glue to be fully set, because if it's still plastic, if you pull it out of the form, any plasticity in that is going to cause it to unwind. So you want to just let it sit until you pull out that extra stuff you have laying around, or you feel it on the sides and it's like glass. And the Unibond, you have to be careful. The stuff it dries like glass, and it'll slice you really badly if you, most of the time what happens is you pick it up and there's like little edges and you just start nicking your fingers, because the stuff is it dries so hard and so sharp. So the last thing, do I have like 10 more minutes? What time?
Anybody needs to leave, it's okay, but go ahead.
Okay. Does anybody have any questions on the glue up?
On the surface that you're getting all of this stuff ready to glue, and I know this is really messy side that you just did, and said flip it over to the other side. What are you laying it on your bench, or do you cover your bench?
I cover my bench with plastic. I just, those like painters, plastic sheets that you can roll out. I usually do it on the floor. You could do it on the bench. And the first piece, this outer face is not going to have any glue on it. So I lay that down on the floor, and then I roll glue onto the back, and then I roll glue onto the other strip, and then I flip it over onto that one. So you never have like a full piece glued up in contact with anything, but it's still going to make a mess. So you definitely want to lay down some protection, whatever it may be. And I would use plastic rather than like paper, because if you use paper, you may end up gluing the paper to the things and start picking it up, and it'll be a mess.
You apply glue to both sides of the leg?
I do. Yeah. You have to roll. I roll it on with a foam roller, and you have to be careful about the thickness, especially the wider the lamination gets. If you had a really wide lamination, it's exactly the same thing as veneering. You don't want to trap this huge like mound of glue in the middle. Most of it will squeeze out, especially when the the plies are relatively narrow in width. But you definitely want to roll it on. And it takes a little while for the Unibond to soak into the roller. So the first couple of plies, you have to be careful not to under apply them, because the foam will like absorb the Unibond and the epoxy. And you just have to make sure that you get a nice like watery coat on there.
Like the foam paint rollers?
Yeah, that's all I use. Yeah, it's easy. I just use the little 4-inch ones. They cost 10 cents.
That was my question too, also,
Yeah.
like that. When you spoke about just flipping them over and doing the other side, I wondered if you were stacking them up in contact with each other.
Yes, I definitely do. Unibond and epoxy are not, they
don't start to cure
They don't start to
instantly.
cure, and they don't cure by contact, and they don't cure by absorption. It's a chemical process. So you have, half an hour. If it's 80 degrees, I think you have half an hour to get everything clamped up before it starts to set a little bit. And even then, it doesn't skim over. It doesn't skim over the way that like yellow glue does. Yellow glue, it gets a skin, but then the inside's wet. It's just, the consistency remains constant throughout. So I'm gonna jump in here, and people who want to stay later, we can talk about things as long as you want. But the last thing I want to talk about is cleanup. And this is a really important step, because this stuff is a mess. One of the bad thing about Unibond is that it dries incredibly hard, and you can't just take a plane to it. You have to take some sort of either edge belt sander or a bandsaw and cut off that waste. I don't have any problem running the glue lines over my jointer once all the excess is off, because they're so thin, they don't really make the blade. It's not like plywood where there's a ton of glue in there. It's really sloppily done. You know, the glue line might be a 32nd of an inch thick. Like if you do these laminations well, the glue line is so narrow that, you know, you'll have to try it for yourself and see what. I never had a problem with it. But you do have to remove all that excess from the outside. And there is a difference between epoxy and Unibond. With epoxy, I just go at it with like a sacrificial hand plane. And I hand plane all the excess and then I run it over the jointer. And I hand plane all the excess off the other side and I run it through the planer. And then I get two, you know, the lamination is parallel and flat on the two edges. And then you shape and do your joinery from there. With Unibond, it's more difficult. And the way that I attack it, and I'm sure you guys will figure out better ways to do it than I have. But all I do is I take the side guides, like this thing, off the form, and I just hang the final lamination about a 1/16 to an 1/8 of an inch over the edge of the form. And I clamp down, you know, the two ends, and then I take a handheld router with a top-bearing flush trimming bit, and I run the router, the bottom of the router on top of the laminations, and I flush trim it to the edge of the pattern. So you have to make sure that your screw holes aren't, you know, within an inch of the top. But basically you just nudge it over a 1/16 and you make a pass, and then you nudge it over another 1/16 until you have a clean edge all the way down. And that'll give you like a pretty flat surface, and you can run it over the jointer. And for me, it doesn't matter how severe the curve is. You can run anything over a jointer. If you take the fence, I mean the guard off, you just start like this and you go and just rotate the whole thing around. I mean, I jointed the bottom of this. I just started with one edge right on the edge. I bumped the fence over all the way. Started with one part and just rotated it around 360. It's, you know, so it works. You can do it. But if you're using Unibond, you definitely have to remove most of that slop first. And using the router is the best way that I've found. Otherwise, you have to do some crazy band sawing. That's not fun, and then you take it to the joint.
It's too hard to scrape.
If you wipe off most of it, you could scrape it. You can definitely scrape it, but if you take an edge tool to just like, I mean, it'll just destroy a plane blade and just tear it up. And, it's so hard. I mean, it's really like glass. That's what it feels like when it's totally dry. But that rigidity gives the laminations a lot of strength and they hold their shape really well. And that's why I like it. So that is, and you know, we've already talked about this. So anybody who wants to stay after, don't shape through the faces because you've got these ugly glue lines, and that's why we do the tapering, so that you can try and maintain the integrity of the faces.
The number of call blocks, it depends on just how long it is, because you keep block.
Yep. Yeah, I put them about this far apart, and I just double stick tape them down before I start, so that they're all about a consistent width, you know, but just about like that, and basically as close as you can get the clamps to each other.
You don't want the call blocks to run into each other on the radius of the curve, right?
You shouldn't have to worry about that because they'll go away from each other as it bends.
No, that's right.
And one thing I didn't mention about clamps is I try to use the clamps with the shortest bars that fit. You can see on some of the pictures that I just ran out of short clamps, so I have like 4-foot bar clamps sticking out. But that adds a lot of weight, it creates torque, and then they sort of run into each other. And if the bend is really gentle, I like to alternate the clamps back and forth, so I'll have some bars sticking down, I'll have the next one sticking up. That makes it easier to get your hand in there. But on that one, I didn't have the opportunity because the way the base was. So, yeah, and that's...
Brad, any question on the durability of Unibond or epoxy, that long-term durability of the bond?
I think it's excellent. You know, the amount of stress and strain that these things on is pretty minor compared to a lot of the applications that they're used for. You know, in terms of conservation, you know, they make boats out of epoxy. It lasts a long time in like crazy conditions.
In the water all the time.
In the water, and you know, in the ocean, like so. And in Unibond, you know, some of Jerry Osgood's pieces are 40 years old now. They look great, so it's definitely.
What was the price of that? Oh,
Go ahead.
How many of these Adagio music stands have you put together?
One.
How long did it take you, Brad, start to finish?
A month. Well, in 2 weeks. So,
Right.
into.
I sort of remember it was a short time.
yeah, well, the backstory is that I thought the photography shoot for the Furniture Masters is usually at the end of May, and I was operating under that assumption until the end of March, at which point I found out that it had to be done April 20th. So I had to get busy. So it was crazy. I mean, I was working like 15, 16 hours a day, every day to get it done. I had to take a couple days off, but yeah, I mean, I can build it really fast. In a short amount of time, spending long hours. And like I said earlier, most of the work was in these sleds, in the forms, in the patterns. You know, as you can imagine, like when it actually comes to gluing up, it takes an hour, you know? But it's all the steps that lead up to that, and then the joinery on the base took a while, just because I was scared of it.
Brad, can you talk about the joinery on the little pieces up top?
Yeah, absolutely. Those are also bent paper laminations, because I didn't want the grain running out. But the joinery themselves are, it is just a half lap that is shouldered a little bit on the bottom so that you can't see the joint. And then there's not a lot of glue surface there, so I screwed in from the back on all of them, and then just plugged it with little pieces of ebony to give it a mechanical. I just didn't think, you know, they're so long, you can apply so much torque to the edge if it drops or something. I didn't trust the glue on, you know, 5/8 of an inch of good glue surface, because you know the two shoulders are end grain on the sides, so they're not going to provide a lot of support. So it's essentially the two face grain places. There's just not a lot of material there to glue together. So I used screws from the back to try and augment that joint.
One's like little
Yeah.
Very impressive.
Yes.